All right, let's talk about rational numbers. Okay, I've got a Venn diagram here, which shows how numbers are nested together because the smaller groups are contained within the bigger groups within the rational numbers. Okay, so this outside group here, we're going to call this the box. The whole box is the set of rationals. Okay, so anything inside this box is a rational number. Okay, well, what is a rational number? Let's go down below and we'll put our definitions down here. So I'll just leave them in the color that I have. Rational numbers are any number that can be written as a fraction. Or as the title of it called, it's called a rational, or it can be written as a ratio. Okay. Fraction, ratio, very similar concepts. Okay, so that includes a whole bunch of numbers. Okay, like 1/3, 1/28, 1/13. Okay, all kinds of fractions like that. But it also includes some other sets that you might not think of as fractions off the top of your head, but they are. Okay, the next biggest set inside there is called the integers. Okay, and this one's a little tougher to describe in words, so we'll describe this one with a mathematical set. Integers are the set. We're going to lead in with ellipses and then -2, -1, 0, 1, 2, and then end with the ellipses. Those ellipses say that the pattern continues to the left and the pattern also continues to the right. So it doesn't stop at -2, it goes -3, -4, -5. So you can kind of say that these are whole numbers that are both positive and negative. So it's not just the whole numbers, but they're kind of like that. Okay, these are the integers. Okay, any number that's listed in here is an integer. Okay, so that's the next biggest set of rationals. And they are rational because you can make any one of these numbers into a fraction by placing it over 1. -2 over 1 is the same as -2. 2 over 1 is the same as 2. So any of those integers are also rational numbers. Okay, the next biggest set in there is the set of whole numbers. The whole numbers, okay? Very similar to the integers, okay? Just a little bit smaller set. And actually, every one of the whole numbers is an integer. Okay? And we'll also describe this one with a mathematical set. Okay? This one actually starts at 0. So whole numbers are numbers 0 through infinity, going up by 1 each time. So 0, 1, 2, 3, and that pattern continues, hence the ellipsis stops. Okay? Okay, and if you notice, all of these numbers that are in the wholes are also represented in integers. The integer is just a bigger set. Okay? So it's like saying all squares are rectangles, but not all rectangles are squares. Okay? It's the same idea. All whole numbers are integers, but not all integers are whole. Okay? And that's why in the Venn diagram we have a smaller circle that represents the whole numbers, which is contained within the integers. Okay? Okay, and then the last set inside here is called the naturals. The natural numbers. Okay? And they have another nickname, but they are very, very much similar to the whole numbers. The natural numbers are 1, 2, 3, 4, dot, dot, dot. So they look almost the exact same as the whole numbers, except they do not contain the element 0 or the number 0. Okay? The nickname for these would be the counting numbers. Okay? And you can see the reason that they're called that pretty simply because when you start to count something, you start at 1. You don't start at 0. You go 1, 2, 3, 4, not 0, 1, 2, 3, 4. Okay, so they're also called the counting numbers. Okay, and if you notice, all the naturals are contained in the wholes, and all the naturals are also contained in the integers. Okay, so all naturals are integers, but not all integers are natural. And all naturals numbers are whole numbers, but not all whole numbers are naturals. Okay, and then all three of these sets fall within the rationals because every number that we have written down can be written as a fraction. So they're all rational numbers.